In this video, we're going to look at exercise 6.3 from the higher textbook. So we're looking at solving quadratic trig equations. We're looking at question 1d. So 4 sine squared x plus 8 sine x take away 5 equals 0. So it's recognizing that we've got a squared sine x term, we've got a sine x term, and we've got a number term. So let's simplify the situation. Let y equal sine x. I'm using y so that we're not getting muddled with too many x's. So if I swap that in, we'll have 4y squared plus 8y take away 5 equals 0. So now we've got a really standard looking quadratic. It's equal to 0 as we want with quadratics. There's no highest common factor, but still look out for one in case. It's not a difference of 2 squares, but again, look out for them. But this is a standard quadratic that we could factorize. So putting this into 2 brackets. Now we've got a few options. We could have 4y and y, or we could have 2y and 2y as our first term. Our factors of 5 are just going to be 1 and 5. So no matter which way I put 1 and 5 here, that would give me 20y and 1y, so that's not going to work. If I put in 5 and 1, that would give me 4y and 5y, but again, that doesn't give me 8y, so neither of those are going to work. Looking at our 2y and 2y here, again, if I put in 1 and 5, I get 10y and 2y, and positive 10y take away 2y gives me my 8y, so I'm good there. Double check by expanding it out. 4y squared plus 10y minus 2y gives you 8y minus 5. So you've got your factorising done. Then we solve these two. The only way you can solve it is if it's equal to 0, so don't let that disappear. 2y equals 1, y equals 1/2, and we've got 2y equals minus 5, y equals minus 5 over 2. So those are our two solutions. Now we can put back in our trig. So we've got sine x equals 1/2, which we're going to solve, and then we've got sine x equals minus 5 over 2, which we're also going to look at and try and solve. Okay. Sine of x equals 1/2. We're going to go for our related acute angle, which is inverse sine of 1/2. It's positive, so I don't need to worry about anything. Typing that into your calculator, inverse sine of 1/2 gives you 30 degrees. Now you might have recognised that that's one of your exact values. If you remember that, great, and you could have just put in your 30 degrees, but it's fine if you're using a calculator for this one too. So let's draw our sine graph to find all of our solutions. So sine graph starts at 0, goes up, comes back down at 180, comes back around at 360. So it's just the 180 and the 360 that you can think about. It's positive 1/2, so we're looking at this part of our y-axis. That's our answer. So we're going to have this answer in here and this answer in here. Those are going to be our two values for x. Very small here, the way I'm drawing this. So the difference between that and my answer is going to be 30 degrees, and the difference between 180 and that answer is going to be 30 degrees as well. So it's all about the symmetry of these graphs. So your solutions are going to be 30 degrees. 0 add 30 is 30. And we've got 180, and we're taking off 30 to find that other value. So we've got 30 degrees and 150 degrees. So those are our two answers for those. Now, the next one, we've got sine of x equals negative 5 over 2. Now you could find your related acute angle, and you could try and type that in. So you could try and type in inverse sine of 5 divided by 2 and realise that you get a math error. This is because you should also know that that is 2.5. Your sine graph only goes up to 1. And it goes down to minus 1. So actually, it never goes as far as minus 2.5. So this is outside our range of possible values. So what we say here is that there are no solutions, but you do need to state that. No solutions. So if you're trying to get your inverse sine or inverse cos of a value that's bigger than 1 or smaller than -1, you're going to have no solutions. So your final answer is actually just our two values here. X equals 30 degrees and x equals 150 degrees.